Welcome to a Foreman deep dive. This week's is on the Docker image build service using Foreman, Katello, and Docker. Adam and Ivan are going to lead us through this. The Q&A app is enabled, so if you're watching, you can ask questions through there or on the IRC channel. Over to you, Adam.
Okay, so hello. First, I'd like to introduce what I'm working on and what I'm trying to do. The basic idea is to allow the user to use the same workflow which user can apply to YAML repositories to Docker images. The Foreman Docker plugin allows us to run Docker images as containers. This way you can deploy services in your infrastructure. But there's one thing you cannot control, and that is the versions of software installed on those images. This is what I'm trying to do. I want to make the user able to take his content defined in Katello and build his own images with those versions of software. So let's start. We want the user to be able to just take his existing infrastructure and, well, use it. If the user wants to run Docker or run Docker containers, he has to have a compute resource of Docker type defined, which is what I have here, the T440. Next, the user should have lifecycle environments. I have testing, QA, and production, but as you can see, I have no QuantumViews in production. Next, I have two products, one called registry, where I keep my Docker images. I have CentOS with one tag, that's 7. Docker host builder, which is the container in which I can build additional images, and staging, which is just a temporary product. Oh, repository, sorry. Next, I have the zoo product containing RPMs in 2 versions. Each package is in older version in zoo 1.0 and the newer version in zoo 1.1. To be able to build images, there's a field in settings called Docker Builder Image. It's the image that is used to build more images. How does that work? We use Dock, a lightweight Python tool with pluggable architecture to build images. When you download Dock, be it from Git or as an RPM, you have to create an image from it. There are no official builds of the image as of now, but you can build your own. So this is the name of my builder image. And as you can see, it's in the CentOS 6-2.v2:5000. That means that it's in my pulp repositories in Katello. Back to the content. I have QuantumView memos, where are, well, of course, memo packages from the zoo product. In version 4, I have new versions, and it's promoted to testing environment. And in version 2, I have, let's say, more stable packages promoted to QA environment. The important packages are Bear and Camel, which I'll be using later. Well, let's see the build form. It's in containers, new image. There's a form which allows to specify the name and the tag of the image, of the resulting image, git URL. The Git repository should contain a Dockerfile. You can specify a certain commit if you want. If not, the head is used. And you can specify new base image. Let's take a look at my Dockerfile. It's just, from CentOS run yum install bear camel. Pretty straightforward. But this CentOS 7 is just a generic image provided by upstream. And we don't know what package versions are in it and what it can or cannot do. To address this issue, to have control over versions of packages on the image, you can specify your own base image from pulp. Here I have CentOS 7, but from pulp. Next, you need to specify compute resource, the machine or thing on which the build will take place. Next thing is use auto-generated activation key. What does it mean? If you leave that checked on, you can select the environment, let's say testing. Oh, damn it. My session expired. Just a sec. Well, sorry for this. Let's wait till it loads. And when it loads, well, finally, we're back. So, when you select image, environment, sorry, you're prompted for a content view. So I have just one, and was testing. With use auto-generated activation key checked, it would create new activation key with name dockero-testing-mammals, which would allow the image we're building to consume content from this environment and this content view. If the activation key with this name doesn't exist, it's created automatically, and all available subscriptions are attached to it. If you don't want this, you can just uncheck the use auto-generated activation key and select your own activation key. Let's just go with the automatic route. Target the Docker registries. Dock allows you to push the build image into registry. Well, it has to be proper registry, not it cannot be pulp repository. So you can say that you want the build image pushed to Docker Hub. Theoretically, why not? The important thing for us is target pulp repository. For now, it's a drop-down box where you can select which pulp repository, obviously, you want the build image to end in. There's one important thing to say. Although you can specify a name for the final image, when you select a pulp repository, the image is accessible under the pulp repository name and the tag. So, demonstrate it. If I made an image with name, this is my test image, and tag latest, for example, and told the builder to push it to the CentOS pulp repository, it wouldn't be accessible under the name I selected, but under CentOS 6-2.we2:5000 / organization name dash product name dash repository name colon and the tag. This is a bit weird because the name just basically gets dumped, but well, this is the way it works. So let's try building something. Name demo1 like test. I have this repository with zoo. Let's say we want to build it on my version of CentOS on T440 compute resource and use content from testing memos environment and later push it to staging repository. Okay, let's fire it up. Now we can see a progress bar, but let's watch this in Dynflow. Here we have actions Docker image create, running, and pending. Oh, sorry, that's not the one we just started. This one's the right one. So, how does it work? We get data from the user in the form. It's passed to the controller, which schedules the actions Docker image create action. This action calls container create, which creates the container based on the builder image. If the image is not present, it is pulled. It's courtesy of the Foreman Docker guys. And the next step is waiting for the run to finish. That's the monitor run action. After the run has finished, we want to retrieve package list. And after that, we want to save the resulting image to pulp. And finally, we want to destroy the build container if everything went all right, because we don't want to keep that around. What for? Let's see if it's finished. Yep. All right, so let's watch this. The monitor run polls the container for its state. And basically, it does so until the container's state is powered down or off. What we can see here is the output from doc from the builder container. And it's lots of stuff. The important parts are here that we want to replace the base image. And here's inserted our command, which downloads certificates from Katello and registers the container into the organization and with the provided activation key. Well, this takes a while, installs all the required packages, and registers into pulp or Katello, let's say. Next, proceeds with the rest of the Dockerfile, which was yum install bear and camel, and we can see that bear and camel are being installed in the testing versions from the newer repositories. Let's see if it's done. Oh, right. When the run finishes, we retrieve the list of packages by running rpm-qa from the newly built image. And here's the list we can see. Next is saving the image to pulp. There were two possibilities which would lead to the same result. One was giving doc username and password and address of a pulp repository, and it could upload the image for us. But I don't think it's a good idea to give our passwords to just anyone, let's say. So I've made a workaround which pulls the newly built Docker image from the Docker socket, saves it to temp on the machine which runs the Katello, the Katello process, and uploads the tar to pulp. And after that, triggers the distributor publish and stuff. So let's see if the image appeared in our staging repository. Let's see, registry, repositories, staging. And we can see that we have one tag with 5 layers, and it's the image we created. So that's how it basically works.
So we had a couple of points over the Q&A.
Sorry. Let's see.
So just concerning the weird names, we have Michael from Pulp saying as a clarification, QA and app on the left there, saying that although the names are suboptimal, they might be coming from Katello. Pulp can serve them all up, and Og mentions that the weird names come from Docker itself as well.
Just once more, I'm sorry.
Sorry, just so concerning the weird names of the Docker containers, Michael says that Pulp can serve up a container by any name, and Og mentions that the names are generated by Docker itself.
Oh, does it? Well, okay, I'll try looking into it.
Please carry on.
Well, are there? Ah, here. So what I've shown you was what I've done up until now, and what I'm planning to do next. The first thing, probably, is mapping Docker images to content hosts, which will basically allow us to let Pulp compute applicabilities, whether the content host, which is de facto a Docker image, if it needs to be rebuilt, if there are available newer packages available for it. Next thing is UI and notifications for this. So when user promotes newer version to an environment, Pulp generates applicability, and user gets a nice pop-up that this and that image is out of date or not in sync with the rest and needs to be rebuilt, and with a possibility to trigger the rebuild. The next thing is to store the build configuration, probably with QuantumView or repository. Maybe this is still unclear. So, you know, when you build an image and there are updates available for it, so you can just you wouldn't have to fill this them. So you wouldn't have to fill the form again. It would be saved somewhere, and you just click rebuild this, and you know how to do it. Rebuild it. Next thing is bulk updates of images in case some disaster bug is found and patches are released to address this. So you can just say, okay, I have all these images and they're all affected, probably. Rebuild them all. And the next thing is provide possibility to keep images up to date without provided Dockerfile. So let's say you just get a base image from somewhere, from upstream, let's say, and you want to have your versions of the packages which come with the base system, let's say. So you could just run some yum update inside it or something. Any questions?
No, not that I've seen.
Well,
Yeah, I have a question.
go on.
Does the Dockerfile have to be in Git?
Well, as of now, it has to be. Is it an issue for you, or?
I was just thinking it might be nice if people can like maybe upload or paste in a Dockerfile as well, so they don't have to store it in a public Git repo. Like just a thought.
Yeah, that I guess that would be nice.
Yeah, we are we are thinking about this additionally, or maybe even using the provision templates to generate the Docker files. The problem is, or usually when you have the Docker file, it's not just the Docker file itself, but there are other scripts in the real life Docker images that are scripts that needs to be run and copied to the container and so on. So that's why we are using the Git repository as the main source of the Docker files, because there is a risk that other files will be needed as well, and then the plain Dockerfile itself doesn't work that well. So that was the main reason for doing so.
Oh, okay. Also, I just have a comment. It looks really good. This looks great, so I'm really looking forward to playing with it and stuff.
Yeah, so as Adam mentioned, we now, one reason for doing this deep dive is basically showing you the current progress and where the stage where we are at. And the next, we also want to feedback for the next step. So there are a couple of questions that we would like to get answered, like where the image configuration or image build configuration should be, or what it should be assigned to. If it should be repository or QuantumView, then if tying it somehow with the QuantumView versions and so on. So making the best workflow that would fit into the whole environment that we already have. And so this is basically the introduction for this. As we now have something working. So maybe we can follow up with discussions and suggestions on the Foreman dev, on basically replying to the mailing list thread about this deep dive, and find more place to discuss. Also, one thing or another next step that we would like to do, or we should be ready to do, is using, let's say, Kubernetes to scale the building process. So right now we are using the plain Docker socket to trigger the containers, as this might not be ready for scaling for bulk updates when shell shock like issue comes up. So but given the technology stack that we are using, it should be just switching the runtime from the pure Docker to the Kubernetes to give us the scaling for free. So that's another thing that we would like to do as the next steps, probably in connection to what Foreman Docker provides. So we are using the code that is already written there to running the task itself.
Yeah, thank you. I've forgotten to mention this. So we have a question. Have you thought about supporting build triggers? For example, post commit hook in Git might kick off a new build. Well, I haven't thought about this yet. It could be done, but do we really want it? Do we really want just to spam thousands of new images with every commit? I would go for keeping this manual, but if that's what the community wants, let's do it.
Justin Sherrill has also added even hooking into QuantumView publish or promotion would be nice.
Yeah, I agree with that. And one of the questions we need to answer first is where to map the image building properties for it to make more sense. So if we map it to the content view and tied the build images to the versions, then yeah, when I publish new version, I would like to see the image build for the version and getting just available there. So this is another step forward. So yeah, we are open to this, and we obviously want to make it in automated fashion, as that's what we are trying to fight with manual building of the images outside of your Katello infrastructure.
Okay, well, I think we're out of questions. So thank you very much, Adam and Ivan. The recording will go up on the website and on the YouTube channel. Unless there's anything you want to add?
Just thank you for organizing the deep dive and all for attendance.
Thanks very much.
Thanks.